Hello, welcome to the first in a long series of videos on electricity and electronics. When I was in high school, I took 3 years of electricity electronics, and our professor let us kind of work our way through a series of workbooks called Navy Basic Electricity and Electronics, once used by the Navy in the 70s. And I'm going to kind of eyeball, that's the word. I'm going to eyeball those books as I go through this series of videos. You can find those, by the way, online. I think they're public domain, and so you can find them. Maybe I'll throw the link into the information of this video. But this is the first one. What is electricity? Electricity is a bunch of unruly electrons going for a run. Of course, when electricity was first being explored, nobody knew what an electron was. You know, there's a story of Benjamin Franklin using a kite to determine whether lightning was electricity. Bzzz, it is. But this is the first video. What is electricity? Electricity is a bunch of electrons. They're actually not unruly. They follow the laws of nature. They're very law-abiding citizens of the universe. But electrons moving through a substance, we call that a current, after the analogy of a river. Electrons are moving through, say, a copper wire. The wire's not hollow. You can't cut the wire in half and say, oh, I can see the hole where the electrons go. That's not how it works. But very, 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 very small. Electricity is electrons going for a walkabout. So let's go ahead and dive in and start with the atom. Now, this is not an accurate picture of an atom. Well, I took it myself. No, this would be what, a helium atom, because it has 2 protons. You tell what an atom is by the number of protons it has. But I'm getting ahead of myself. We might say that an atom has 3 basic components to it. It has a proton, which we say is positively charged. It has electrons, which are negatively charged. And then the green balls here represent what's called the neutron, which surprisingly are neutral. You ever heard a neutron walks into a bar and orders a drink. And when he's done, he asks the bartender, how much will that cost? And the bartender says, for you, no charge. So neutrons have no charge. This is the standard layout of an electron, although it doesn't really look like this. It actually looks more like this. And it's very, very small. It's like 1 angstrom, which is like an A with a halo on it, the symbol for angstrom. An angstrom is about 100 picometers, which is 1 × 10 to the -12th in size, if you know scientific notation. I'm sure we'll get into scientific notation, but just say, for now, it's very small. And so here's kind of a picture, as it were, of the nucleus with 2 neutrons and 2 protons. So electrons, we might think, some of the early explorers of the atom thought of it a little bit like the solar system, where you've got the sun in the middle and you've got the planets going around it. It's not exactly like that. In fact, electrons are really nowhere until you try to measure them, and then they say, okay, I'll show up for your measurement. But until you measure an electron, they're just kind of, it's a probability field. I might be here or I might not. Anyway, that's way beyond what you need to know to plug in something like this lamp right here. But the bottom line is electricity is these electrons going for these negatively charged particles. We call them particles, going for a walk. That's what electricity is. So things to think about. So electricity is electrons moving through a medium like a copper wire. As we'll see, some mediums let them go. Some are like none shall pass. We call those insulators, rubber and things like that. You're not likely to get shocked in a lightning storm if you're in a car with really good rubber wheels, because rubber is resistant to electricity. There are other things like copper that are actually quite conducive. Conductors, we call those. Insulators don't, conductors do. But electricity is electrons moving through a medium, not a meteor. That's something different. Wires are solid. Again, as I said, they don't have holes on them. This happens on such a small scale, we can't possibly see them with our naked eye. Most of an atom is empty space. You remember how we had that? We had those 4 particles in the middle, and we had those 2 electrons out there. That most of an atom is empty space. The electrons are actually like 100,000 nucleus-sized spaces away from the nucleus. So the overwhelming part of an atom is emptiness. In fact, there was somebody who discovered this, by shooting energy or photons through a foil, I think it was, and most of them went right through. Only some of them bounced back. And so that person concluded, most of the atom must be empty space. An electron is actually much, much smaller than the proton, the positively charged particle. The electron is the negative charged particle, the proton, the positively charged particle. So an electron is much smarter, 1/1845th the size of a proton. So that's just a little bit to get us going. Different atoms have different numbers of protons and electrons. The way you tell the difference between, say, oxygen and silver is they have a different number of protons. And because of that, they have a different number of electrons, and they have a different number of neutrons. Hydrogen's the smallest atom. It has one proton, and when it's normal, one electron, although sometimes it gives its electron away. I won't go into it. Hydrogen in its natural state doesn't have any neutrons. Although if you watch Spider-Man, where Doc Ock tries to make tritium. Tritium is hydrogen with 2 neutrons, as I recall. That's not important right now. What do you need to know? You need to know from this video that electricity is electrons going for a walk. And there we have it. We have begun our journey through electricity, basic electricity, and electronics.